Alright, what up geometry peeps? Today is special types of parallelograms with algebra application. So, we're taking all the properties we know about rectangles, rhombi, and square, and now we're putting some x's and numbers to them and finding some missing parts. So, let's take our note sheet and begin by labeling each piece. We're using rectangle A, B, C, D, and we got two problems that go along with this shape. So the first problem says if AE, we're going to put E in the middle here, if AE is 10, find the length of BD. So we want the length of this whole piece here. Now, you got to use what we know about the diagonals of a rectangle, and if you remember, the whole diagonals are congruent, and also since it's a parallelogram, they bisect each other. So we know those are equal and those are equal. So we know this is 10. I'm going to erase the yellow part now. This is 10 and this is 10. So that would mean BD is equal to 20. 10 and 10 give me 20. Alright, so that works out good. Now I'm going to erase this just to the 10s just to give us some more space to find the other pieces. I'll move E up a little. Now, this says the measure of DEC is 110 and find every other missing angle. Say, what? That's 110. And yes, the expectation is we can find all the other ones. Now, how do we go about doing this? Well, this one's easy because vertical angles. We know this is 110. And here, we know those two make a straight line. So because of linear pairs, 180 minus 110 is 70. And that's 70. Alright, so we got that piece. That piece is pretty easy based on everything we already know. Now, here's the trick. Alright, we know that this is an isosceles triangle. So pretty much we have this. Let's do this bottom right here just because it's standing upright and it's right in our face. So we have this, knowing that's 110 and these are the same. So we have 180 minus 110 gives me 70. So we know between these two we have to split up 70 degrees because we know they're both congruent because it's isosceles. So I would get 35 and 35 degrees, all due to the fact it's isosceles triangle. So I know this is 35 and this is 35. Now, there's a few ways to go about this the next way. Here you can find these two by subtracting that from 180 and splitting the difference, or you know this is 90. So either way is okay. So 90 minus 35 gives me 55. Since it's isosceles, you know this is 55. And now the problem's pretty much done because you know these two triangles are the same. So 35, 35, or you can work your way around with the 90s. 55 and 55. So, given one single angle in a rectangle, you should have the ability to find all the other missing angles. Alright, so that's part B. So those are the applications of a rectangle. Now let's look at more rectangle problems. This is find the values of x and y in rectangle. TSRV this time. TSRV. And we're going to call the middle one W. So VW is 2x plus y. WS is 36. RS is x minus y. And VT is 9. So use what we know about a rectangle. We know the diagonals are congruent. Oh, and I forgot my plus sign there. So we have 2x plus y. 2x plus y is equal to 36. And we have x minus y is equal to 9. So I have two equations with x's and y's. So we have to solve our system. And fortunately for us, we don't have to multiply because we already have opposites on my y's. So 2x plus 1x is 3x. 36 plus 9 is 45. So x we get 15. Now we just go substitute that back in. I'm going to use this bottom one because it's in a pretty simple form. So 15 minus y equals 9. Subtract 15. Get negative 6. Divide by negative 1. And y is 6. So 15, 6 is my answer for x and y. Okay, again, just taking the properties of a rectangle and applying it to our algebra. Alright, using rhombus, B-E-A-R, B-E-A-R, and we're going to put an S in the middle. It says BR is x squared, and BE is 9x minus 14. Well, based on the information given, we're given two sides of a rhombus. Two sides of a rhombus. We know that all the sides of a rhombus are congruent. So let's go ahead and set those pieces equal. Okay, pretty easy. Once you know the properties, it's not difficult. Now, we have an x squared, so whenever every x squared, we know we have to get equal to 0 in factor. So I'm going to move my 9x over, and I'm going to add my 14. So now we need to find two numbers that multiply to positive 14 and add to negative 9. That gives me x minus 7, x minus 2, negative, negative. So my solutions are x equals 7 and x equals 2. Alright, so we got two solutions. Now, the second part of this problem wants us to find the perimeter. Well, since we have two solutions, we're actually going to have two different pieces, two different answers, two different perimeters. So I'm just going to use this side. 7 squared we know is 49. Well, all the sides of a rhombus are the same, so we know it's 49 times 4. So when x equals 7, the perimeter is 4 sides of side length 49. So that gives me 196 units when x is 7. Well, when x is 2, we know this is 4. So 4 sides that are 4 units long, I know my perimeter is 16. So again, use the properties of a rhombus to make your life easier when finding the final answer. And then the second application we have here is angle BSE is 15x minus 15. So we're talking about this angle here. But fortunately for us, we know the diagonals intersect at 90 degrees in a rhombus. So that makes our life really easy because we know 15x minus 15 is equal to 90. Any angle given to us in there is equal to 90. Add 15 to both sides. Whoa. Add 15 to both sides. We get 15x equals 105. Divide by 15. And x is 7. And that's all they wanted there, was to solve for x. Alright, so that's applications of a rhombus. Now let's go into applications of a square. And if you remember, squares are actually nice. These applications are pretty easy because a square's got it all. So once you go and you actually look at the information, whatever you think it is, based on all the properties you've seen, you're probably right. So we have H, A, W, K, S. You see how I did that in red? I get it. Okay. So find the measure of angle AHW. AHW. So we're talking about this angle here. Well, we know it's a square, so this is 90. But we also know that the diagonals bisect every angle. The diagonals are angle bisectors. So we know this is 45 and 45, and that's the angle we're looking for right there. So the measure of angle AHW is 45 degrees. All right, now they want us to say HSK, angle HSK. So this angle right here is equal to x squared minus 10. Well, again, the diagonals of a square cross at 90 because a square's got every property possible. So we know x squared minus 10 equals 90. Now, solving for this, you see an x squared, you might think you have to factor, but we do not have an x term. So let's actually just get this x squared alone. And we get x squared equals 100. We square root both sides. So x equals plus or minus 10. Whenever you square root both sides, you have to remember your plus or minus, because 10 squared is 100. And negative 10 squared is also 100. So both answers count. Alright, so we get plus or minus 10, and if we substitute that in, those would both work. Because you have, let's check it. You have 10 squared minus 10. Does that equal 90? Well, 100 minus 10 equals 90, so that works out. And negative 10 squared minus 10 equals 90. Well, 100 minus 10 also equals 90. So it's important that you include both solutions in your answer. Alright, that's all I got. See you later.